All right, guys, make sure you put number 13 on here. Right. Make sure you put number 13 on here. All right, again, mean absolute deviation. When have we seen that word? Allie Claire?
It was on the test.
It was on the test. That was the vocabulary word that I had forgotten to take off, so I gave y'all that answer that hopefully we all filled in since it was on the board. All right. Mean absolute deviation, guys, y'all saw it actually before the test. Y'all saw it before the test. What was that?
You saw it last year.
I don't think y'all did this last year. All right, Carson? It was in our notes. All right, in fact, if I go back to the vocabulary list that is on number 10, and it is numbers 10, measure of variation, sound familiar? Quartile, sound familiar? Lower quartile, upper quartile, inner quartile range, outlier. And then number 16 was mean absolute deviation. And we put a star next to that because I said we're going to discuss that at a later time. This is that later time. This is it, okay? So now, when it's accidentally on your test, is it accidental? No, because now we're talking about it. Now we're talking about it. Now, if that vocabulary word is on there, I expect you to know it, okay? So, guys, let's read the definition, and then y'all know me. Definitions sometimes end up sounding like the Charlie Brown teacher, womp, womp, womp. All right, they go in one ear, out the other. We got to break it down, okay? So we're going to read the technical definition, then we're going to break it down for what that means. All right, hey, I need us to focus, okay? All right, this is number 13. All right, mean absolute deviation. This definition is on number 10. We're going to read it and we'll break it down a little bit. It says the mean absolute deviation is the average distance between each data value, which means basically each number, and the mean of the set of data. So that's nice. That's great. That's wonderful. So let's make it a little bit simpler. Mean absolute deviation. All that saying, we're going to simplify it. Same definition, just a few less words. Mean absolute deviation is the average distance from the mean. The average distance from the mean. That's what it's saying. All right, that's the exact same keywords. I just took out the extra. The average distance from the mean. All right. So let's kind of talk about that and maybe apply it to some real life situations. Okay. First of all, when I'm talking about the distance from the mean, what is another word for mean? What's another word for mean, Allie Claire? Average. It also means average. Okay, so we're really talking about, let's just focus on where it says distance from the average. All right, so the way I'm going to relate that to y'all's real life, on Monday, up on the board, I put y'all's test average. In fact, I even labeled it as your class mean. All right, so up on the board was your class average, which I believe was a 90 for the test from Friday. All right, so your class average was a 90. Now, does that mean that you made a 90 on your test? No, because your test is the data that gave us the average of a 90. So what you hopefully did when you saw your score was you looked at your score and decided, how far am I from the class average? Am I higher than the class average? And if so, were you a lot higher? I'm sure y'all took that into account. Because when you see that average, are you just thinking, oh, I'm higher than the average? Or do you go, yes, I'm way higher. Oh, I was almost at the average. Next time I want to be further away. If you were lower than the average, then that's an indication of, oh, I might want to work a little bit harder, spend a little bit more time studying and reviewing and looking at my vocabulary. Okay? So when you got your test back, were you able to look and see where you related to the average? Were you higher? Were you lower? Were you close? Were you far? That's what we're going to find. We're going to find out how far each, in this case, it would be each test is from that class average. Now, does it just say find the distance from the mean? No. So after we find out how far each of y'all's test is from that average, then we're going to actually find the average again. So that means we're going to find the mean a second time. Okay. So we're going to find out how far it is away from the mean. Then we're going to find the mean of those numbers. So what's the first thing we have to find? The distance or the mean? We got to find the mean. Then we're going to find out how far each piece is. And then we're going to find the average of those. All right? I promise you it's a lot easier than what you're thinking right now. All right? So on the notes today, what I've done is I've actually broken it down into a chart form. All right? I broke it down into a chart form. Oop, wrong direction. All right? Now, on the quiz on Friday, I'm not going to give you this chart. On the work tomorrow, we're going to practice without the chart. For today, it's the first time you're doing it. So I thought, let's use a chart. It'll help us see how everything's organized. Okay? All right. So in the first chart, it's telling us the morning temperatures at 10 a.m. All right, and we want to find the mean absolute deviation. You'll see this column labeled data. Remember, data is the information. These are my numbers. So these are the numbers I'm using. Instead of being listed out like normal, I've already put them in the chart for you. Okay? So these are the numbers we're using. If I'm going to find the mean absolute deviation, what's the first thing I need to do to find the mean absolute deviation? Caleb? Add all the numbers together because that's the first step in what process? Finding the mean. So the first thing we got to do is actually find the mean. If we want to find mean absolute deviation, we got to find the mean. So, guys, please remember, there is one of me. There is 30 of y'all. Can I look and see what each one of you is typing into your calculator? No. So, I know it seems a little silly. I want you to write it down because sometimes that's where the mistake is happening, okay? So, let's write down what all we're going to add up. So, we got 50, 54, 54, 55, 59, and 61. That's 1, 2, 3, 4, 5, 6. 6 numbers there. All right, so once I type that in and add it up, what does that give me? Taylor? 333. Excellent. Now, is 333 my mean? No, there's one more step. What else do I have to do? Haley?
Divide it by the number that you're given.
Very good. And how many numbers were we given?
6.
So we're going to divide it by 6 because that's the number of numbers. So 333 divided by 6, what does that give me, Ellie? 55.5. So the average temperature at 10 o'clock in the morning is 55.5 degrees. Now what we want to do, we have the mean. Now we want to find the distance from the mean. So for each of these numbers, I want to know how far is 50 from 55.5. Now, I know most of you can just look at this and go, boop, it's this many spaces away. All right, are all of my numbers going to be easy to go, boop, it's this number? No. So I don't want to just depend on being able to look at it and tell. I want to know mathematically how to find it. How do I find how far apart things are? We subtract them. All right, it's like finding the range. So what number should be on top? 55.5 because it's bigger. You always want to put the big number on top. If the big number is not on top, you could end up with a negative. Can we have a negative if I'm finding distance? No. Remember, you're not going to tell someone, go negative 3 miles down the road. Right? No negative distances. All right? So right here, to find out how far apart these are, we're going to take our mean because it's bigger. We're going to put 55.5 and we're going to subtract 50. All right, what's 55.5 minus 50, Ethan? 5.5. Very good. All right, and guys, we're going to have to do this for every single number because do I just want to know how far 50 is from the mean? We want to know how far every single number is. So, to do 54, what am I going to do? What do you think, Morgan? To find out how far 54 is, what do I have to do? Kayla, what do you think?
Me?
Yeah.
I would subtract 55.5.
Very good. Minus?
54.
Minus 54. Guys, we're taking the mean and the data value. And we're subtracting them every time. We want to find how far apart they are. We're finding the range of those two numbers every time. So when I subtract that, what does that give me? Taylor? 1.5. Now, my next number is also 54. Is that magically going to give me a different answer? No. Not if I did my calculation correctly. So I should be able to bring my 1.5 down here as well. Okay. All right, next number. What am I going to do to find that distance? Nick? 55.5 minus 55. What do I get, Nick? 0.5. You can put 0.5. You can put 0.5. It's up to you. Okay, what about my next one? How am I going to subtract that one? Haley?
59 minus 55.5.
Awesome job. And you'll notice she flipped them around because which one's bigger? 59. So that one has to be on top. What do I get when I subtract those? Braxton? 4.5? I don't think so. 3.5. Please remember, guys, when you're subtracting these, you would have to add a decimal and a 0, so that's going to require borrowing, which is why we got the 3 and not the 4 there. And got you. All right. Last one. What am I going to subtract, Allie Claire?
You're going to subtract 55.5 from 61.
55.5 from 61, so 61 goes on the top. And what do we get when we subtract those two, Sophia?
5.5.
5.5. Okay, so now, do I know all of my distances from the mean? Yes. What's the last thing I need? The average. What does it mean if I'm finding the average? What's another word for that? The mean. So guys, you just created 6 new numbers. And with those 6 new numbers, we're going to find the mean. All right? So, how do I find the mean? Add them all up. So, 5.5, 1.5, 1.5, 0.5, 3.5, 5.5. You notice how I lined up my decimals? Remember that? Way back from first 9 weeks? All right? Add those up. What do we get when we add them up? What is that, Anna Claire? 18. Thank you so much. And Anna Claire, is that my mean? No, what do I have to do now? Divide it by how many numbers there were? 1, 2, 3, 4, 5, 6. So let's divide by 6, which gives us 3. So that 3, and I'm sorry, ran out of room. That 3 is my mean absolute deviation. All right. So on average, how far away are my temperatures from the average? 3 degrees. Okay. Do you see how that's telling us how they're spread out? On average, they're 3 degrees away from the average, or that middle, that center number. So on average, they're 3 degrees away from a center. Let's look at the next one. Now what are we talking about? Afternoon temperature. So we're still talking about temperatures, just now we're looking at the afternoon. We're still finding mean absolute deviation. So what's step 1? Find the mean. Okay, y'all know how to do that. I'm going to write my numbers in. So 65, 71, 74, 74, 82, 84. And what am I doing with those numbers? Adding them up. What do we get when we add those up? Okay, let's fast with that calculator. 450. Make sure you write those numbers down too. All right, 450. Now what do I need to do with that 450? Because it's hopefully not the mean. It's nowhere near the center. Thank you, Peyton, for raising your hand so I can hear you.
Divide by the number that was given to you.
Which is 6. So we got... You didn't do it wrong. You just yelled out the wrong number. Okay, so we're dividing by 6. All right, so good job, Peyton. Thank you. Okay, so what do I get as my answer, Ledger? 75. Okay. Oh, man. Okay. Yes, quietly, though. All right. Okay. 55.5. All right. So now, okay, guys, I know we're getting our snack out, but you got to focus. It should not disrupt our class. If it disrupts our class, then we don't need to do it. Because because math is more important. I'm sorry. All right. You get breakfast, you get lunch. Math is important right now. All right. Difference between each data value and the mean. All right, so now we've got to do that finding the distance there. So what am I going to do to find how far apart 75 and 65 are, Caleb? Subtract. So we get 75 minus 65, which is 10. Then we're going to do it again for the next one. So what do I put there, Carson?
75 minus 71.
Which gives me 4. 75 minus 71 gives me 4. Next one. Kira?
75 minus 71.
75 minus 74. We're on 74, which gives me what?
1.
1. All right, the next number is the same, so let's just bring that down. All right, then we have 75 minus 82. Is that how I want to write that? No, we've got to flip it. 82 is bigger, right? Very good. So we got to put 82 on top minus 75, which actually gives me 7. And then for my last one, what am I going to put there, Liam?
9.
9, and how did you get the 9?
By subtracting 84 from 75.
84 minus 75 is 9. All right, so now I have all my distances. So if I wanted to know how far away from the mean is 74, could you tell me? How far away from the mean is 74? 1 degree. Okay. All right, but that's not what it's asking us. We want to find the mean absolute deviation. So now I've got to find the mean again. So let's write out all those numbers. 10, 4, 1, 1, 7, 9. When I add them this time, what do I get? When I add them up, what do we get, Taylor? 32. And what do I have to still do to that 32? Because the mean isn't just adding. Ellie? Divide it by 6. And what do we get there? Sophia?
5.36.
5.3 that goes on forever. How do I show that that 3 goes on forever? Put a line over the 3. Excellent job. Okay. We have one more thing to answer. It says, compare the variation in temperature at each time of the day. Remember, this is our morning. This is our afternoon, our PM. Okay. What does the word variation mean again? I heard it. Make sure you're raising your hand so I can actually hear you answer, Braxton. How things are spread out. So if this has a smaller number, if these temperatures are only on an average 3 away from the center, and these temperatures are on an average 5.3 away from the center, what do I know? How can I compare my AM and my PM temperatures? So morning temperatures, instead of saying not as spread out, are y'all okay with me saying are closer together? Is that okay? Are closer together than afternoon temperatures. Look, I forgot the right there. All right. So morning temperatures are closer together than afternoon temperatures. I've answered my question. Does that compare morning to afternoon? Yes. So that is the end. You're going to be doing this on your homework.